this video, we will discuss about the joinery and construction details of panel doors. As an example, I will be using a double panel door model to show different wooden joinery required in a panel door, like joinery of top, middle and bottom rail with the stiles, and how frame or casing is fixed with the wall and others. So let's start with it. So first let's remove the walls and see how the overall casing of the door will be. You can see the thickness of the frame on which the door is attached is actually covering the whole wall. This is different from the door frames which comes usually at the center of the wall, having single or double rebate according to the need. But here we cover the whole wall. In this case, the wall is 9 inch thick, so the casing or frame is thicker. But if the wall thickness is reduced, the casing or frame size will reduce according to that. Okay, so now remove all the elements of the door and start installing them one by one, and in that process I will explain you how they are joined all together and what are the dimensions for them. First, let's start with adding splayed rough ground. It is installed outside the wall and nailed to it to get a firm hold for the casing or frame of the door, which we will add later. We will add this splayed on both inside and outside of the wall. Now when we look closer to it, you will see how the splayed is attached just outside of the wall and it is nailed to it. One more thing to look is this: splayed is installed before plaster. You can see that the splayed ground is not totally flushed with the wall. A portion of it is extended inside and grooves are provided in it to provide backing for this splayed ground, which we will add after this. The length of this wooden splayed member is 75 mm and thickness is 19 mm. The thickness of the wall you can see is 9 inch or 230 millimeters. You can see the splayed rough ground is extended 19 millimeters from the wall. Now when we remove the wall, you can see how the splayed rough ground is arranged. When we look inside the joinery of these splayed ground, we can see that they are actually joined by using haunched mortise and tenon joint at the top. Now let's separate the left splayed ground from the top one and see how haunched mortise and tenon joint is done. In the top splayed ground, you can see the haunched tenon is created. The tenon is provided in the lower half portion of the top splayed ground, and on the other top half a little haunch is provided. In the total width of 75 millimeters, we can provide the top haunch of around 8 to 10 millimeters. And in the lower half, we can extend the tenon to full length. Tenon here is 5 mm thick, provided in the center of the top splayed ground. Now let's get to know why this notch is provided in the splayed ground. This notch is provided at regular distance to hold the backing in it, which helps in tying the rough splayed ground on both sides of the wall. The notch provided is 50 mm wide at one side and 20 mm wide on the other side. Usually, the wider opening of 50 mm is provided on outer side and smaller opening of 20 mm is provided on the inside. The depth of the notch inside the splayed ground is 19 mm. Now it's time to add next element, that is backing. Backing acts as a dais between the rough splayed ground on both sides of the wall. Backing is just notched inside the splayed member, just like a Lego joinery. Now let's remove one of the backing from the splayed member and see how the dimensions of the backing goes by. The length of the backing will depend on the thickness of the wall or the distance between the two splayed rough ground. In this case, it is 9 inch or 230 millimeters. The width is 50 millimeters and thickness is 19 millimeters. The notch is provided at the center on both sides of the backing. By providing a 15 millimeter from both sides on the 50 millimeter width of the backing, a dovetail is created to fit into the notch given in the rough splayed ground. The dovetail, which has wider flange of 50 mm outside and smaller flange of 20 mm inside, helps in holding the rough splayed ground all together and maintain the stability of the casing or frame. When we hide the walls, we can see how the rough splayed ground is tied together with the help of backing. These backing are provided at regular intervals on the length and width of the door opening. In this case, the clear height door opening is 2100 mm. For that distance, we have provided 4 backing at a distance of 600 mm center to center, starting from the bottom. We can also provide these backing by equally dividing the height and width of the door size. At the top also we have provided backing starting from the middle of the opening. After backing is done, we start with providing casing or frame. It can be single rebate or double rebate, that is, it can be used for single door or double door in a house. In this case, we are using a double rebate casing. The backing and the casing are joined together and it covers the rough splayed ground as well. Now to see what's inside and how the casing is joined, let's remove the splayed ground and backing. We can see the only casing now. Now let's separate the top portion of the casing and see how it is joined with the vertical members of the casing. We can see how rebates are created on both horizontal and vertical members so that the top horizontal member can rest on the vertical member of the casing. Now let's check out the dimensions of the casing of both vertical and horizontal member. Overall width of the casing will depend on the width of the wall. In this case, it is 266 mm. The thickness of the casing is 38 mm in total, in which rebate is given on 19 mm thickness, and the width of the rebate is 30 mm, which is given on both sides as it is a double rebate casing. The guidelines here shows as how the top part is resting on the vertical members and which rebates are resting on one another. The top member of the casing is divided into 4 equal parts with rebate. Now let's put back the top member to the vertical member and see the whole thing with the walls. Okay, so we have now installed the rough splayed ground, backing to support rough splayed ground. Then we installed the casing or frame for the door shutter to fit on. And to join the door shutter to the casing or frame, we use steel hinges. Hinge is a mechanical bearing kind of equipment which connects both casing and door shutter and allows the door to have a rotation around a fixed axis, and it also holds the weight of the door shutter. Based on the height and width of the door, number of hinges to be used is decided. Here I am using 2 hinges, one at the top and one at the bottom. To know how these hinges are joined, let's get inside by removing all other elements one by one. When we get closer to an already attached hinge, you can see one end of the hinge or one flange is fixed to casing, and other end, which is attached to the door shutter, is free to move. We will see the joinery of the door shutter and the hinge after this. The center of the hinge, also known as knuckle, helps in rotating the flange of the hinges. Now let's detach the hinge from the casing. When we do that, you can see how a niche or house is created in the rebate of the casing. The niche can be equal to the thickness of the hinge flange or less than that. We can also add the hinge without the niche to the casing as well, but that will increase the gap between the door shutter and the casing or frame. So to minimize that gap, we provide niche on both casing and the style of the door shutter so that the hinge flanges can be housed in that easily. Here the hinge size we have taken is 100 mm by 30 mm by 2 mm. So the niche in the casing will be 100 mm long and 2 mm in depth, and the width will be 30 mm. The holes of 6 mm dia is provided on both the flanges of the hinge as well, so that it can be screwed to the casing. The arrangement of the holes can be zigzag or in a straight line as well, depending on the width of the flange and length of the flange and the size of the door it is handling. The holes can be in tapered form also, starting from 6mm dia and ending at 4mm dia in the end, which is not shown here in this hinge. The same way we joined our flange of the hinge to the casing, we also have to join another flange of the hinge to the style of the door shutter. Before that, you can see here the gap between the door shutter and the casing. This gap is less here because we have given niche in the casing and the style to house the hinge. Otherwise, this gap can increase and is not good for a door closer. Now to see how hinge is joined to the style member, let's get inside by detaching the door shutter and moving it away from the hinge. Now we are able to see the small niche provided in the style for the flange of the hinge to get housed inside it. The dimension here will be same as we used in casing. Let's copy a set of hinge and place it to the style to make it clearer. Now let's get a section from the top to see the detail of how casing is joined with the door shutter. We can see in the plan the arrangement of the hinge. The center portion of the hinge, also known as knuckle, come outside, and one of the hinge is fixed to casing which cannot move or rotate, and other flange which is attached to the door shutter is free to rotate at a fixed angle. Now after hinges are attached to casing and door shutter, it's time to know how the door shutter is made and the joinery required in it. So first we will start with the joinery of style with the top rail. There are two vertical style members used in this double panel door. One is attached with hinges and other is at the end of the door width. The style is joined with the top rail by using horns, tenon and mortise joinery, the same way we joined the splayed rough ground previously. Now let's X-ray the joinery. You can see how the tenon is inserted to the full width of the vertical style member. We can also separate the top rail from the vertical style and can see the horns tenon given in the top rail and the mortise provided on the vertical style member. Let's move back the top rail back to its position now. On the other side of the top rail, same horns tenon is provided. We will see the dimensions of the top rail here, including the dimension of the horns tenon. Top rail is 100mm by 30mm, in which the thickness of the top rail is 30mm. The haunch is given of 20mm in width, extending from the center of the top rail and covering the top half portion of the top rail. The thickness of the haunch and tenon is 10mm. In the lower half of the top rail, the full length tenon is provided, which is 100mm. This length can vary depending on the width of the vertical style member in which it will be inserted. We can see from the total width of the top rail, which is 100mm, top half is given for a haunch and lower half is given for full tenon. On the other side of the door shutter, we will join another vertical style member. When we X-ray the joint, we can see the same horns tenon joint here as well. Only horns tenon and mortise will not complete the joinery here. We need to tighten the joint by providing extra wedges on both top and bottom of the lower half tenon. By using a hammer, we insert these wedges inside till the joint gets tight enough. And when it is done, the rest of the wedge is removed and it is flushed with the door shutter. To see how it is done, let's get inside the joint again. Let's separate the style from the top rail and see what's inside. You can see two wedges are provided, one at the top and one at the bottom. Usually the thickness for these wedges are 10mm on the outside. The dimension of the style on both the sides is 100mm by 30mm. In the same way, we will join the middle rail with both the styles. When we X-ray the model, we can see the same horns, tenon and mortise joint on both sides of the middle rail, which is inserted on both the styles and holding them together. and it is tightened up with the wedges. Let's separate the joint of the middle rail and the stile and see what's inside. The size of the middle rails is also same as the top rail, that is 100 mm by 30 mm. Now we will add the final rail in the shutter, that is bottom rail. Bottom rail plays an important role in holding the weight of the shutter, so it should be bigger in size than the top and middle rail. It is because at the free end of the door it is more likely to drop at the nose because of its self-weight and gravity. So to avoid that, bottom rail acts as a cantilever and provides stability. When we X-ray the bottom rail, we can see there are two horns tenons in the bottom rail. Now let's separate the stile member from the bottom rail and see what's inside. We can see there are two tenons used in the bottom rail, which is different from the top and middle rail, which have tenons on the lower portion. The size of the bottom rail is 175 mm by 30 mm. Rest of the tenons are divided as shown. Now comes the insertions of panel in the door shutter. Panels are inserted before the final fixing of the stiles and rails. When I select the panel and do the X-ray, we can see the blue lines how they are inserting inside on all four sides of the panel, which includes both the stiles and also top and middle rail as well. To get more clear view, let's dismantle all the rails and stiles in which the panel is inserted. We can see the groove inside all stiles and rails given to house the panel in them. The groove size can vary from 10 mm and more depending on the size of the panel. Here I have given a 10 mm groove. In the similar manner, the second panel can be inserted. When the panels are done, we need to cover the joints between the rails, stiles and panels. The best way to do is to use the moldings. Moldings are the wooden strip used to cover the transition between spaces or for decoration purposes. As in this case, we are covering the joint between the rails, stiles and panels. It also acts as a decorative element. Moldings can be created in many profiles and sizes. Let's cut a section and see the profile of the molding used here. Moldings can be given on both inside and outside depending on the user. Let's remove all other elements and see the section of the single molding. The size of the molding used here is 45 mm by 20 mm. Let's go to section again and see the size of the molding on the panel. We can use nails without heads to join the molding with the rails and panels. In the similar way, the moldings in the second panel can be installed. Let's cut another vertical section and see what's going inside. You can clearly see the whole joinery mechanism inside as to how the panel are grooved inside the rails and stiles, and then moldings are covering the rail panels and stiles. Our shutter is complete now. All other joints in the shutter like mortise and tenon joints between stiles and rails can be joined by nails or wooden dowels. We also use Fevicol or other wooden glues to further strengthen the joints. After that, let's get our wall back. And now to cover the joint of wall and rough splayed ground which we added in the beginning, we will use another wooden strip known as architrave. Architrave is mostly used to denote the style of moldings which is used to cover the frame of the door or other rectangular openings. Let's separate the architrave from the splayed member. We can see how it is covering the whole joint. Now let's cut a section through the wall and see the overall section at lintel level of the door. In the section we can see the profile of the architrave. The size of the architrave is 100 mm by 57 mm. By removing the wall, we can see how architrave is sitting over the rough splayed ground and covering it all together. Next, we will install the baseboard or skirting to the wall. It is used mainly to cover the joint between the floor and the wall surface. It also covers the uneven edge of the flooring next to the wall. It also protects the wall from kicks, abrasions and furniture and can serve as a decorative molding as well. It can be of any desired profile. The height of the skirting can go from 100 mm to 200 mm. Here I have used 175 mm high skirting. The maximum width here is 25 mm and minimum is 12.2 mm. And one more thing to clear, the architrave and moldings in the panel and on the wall, the corners of them are joined diagonally to get a perfect joinery. Now let's cut a section from the top and see the overall plan of the double panel door. Let's remind the few dimensions which I have already explained previously one by one, like the sizes of the wall thickness, casing, rough splayed ground, opening size, width of shutter, etc.